of the Always Believe House. Oh, today we're going to continue with exponents, and we're going to do scientific notation. This is something you should have had in 8th grade. I don't know if you did it or not with the COVID shutdown after spring break. So we're going to start, and you're going to learn how to write numbers in scientific notation. So a magical whiteboard appears, and you can see the scientific notation problems up here. Scientific notation is a way to write really big, small, or really big numbers with a power of 10, okay? You're going to use this a lot in chemistry and in your science. Like the distance between here and, let's say, Jupiter, you'll write that with scientific notation. If you wanted to write that in miles, it's many light years. But anyway, let's just go on, and we're going to write these numbers in scientific notation, and then I'll show you what happens on a calculator when you do this, okay? So you can't do this on a calculator. Okay, so the first problem, we have 55, and we're going to write it in scientific notation. When you write a number in scientific notation, it's always going to be in this form. You're going to have your number, and the decimal is going to be one digit to the left, and then you're going to put times 10 and an exponent. So all of your answers will look like this. You want the decimal with one digit to the left. Write down probably 3 digits is the most you do in scientific notation. Then you put times 10, and the 10 tells you how many times to move the exponent. So we're going to write numbers in scientific notation first, and then we're going to take numbers in scientific notation and write them normal. Okay, so number 1, we have 55. So the first thing you want to do is start at the left of the number and go to the right. So if I start at 55, my first number is 5, and then I'm going to put an arrow tip right after the first digit. That's where my decimal is going to go. So I'm going to write down 5.5. Now then, how many times did I move the decimal to the right? I moved it once, didn't I? So write down times 10 to the first power. If you were to punch that in the calculator, you would get 55. Okay, let's make a bigger number here, because these, or let's just go to the next one. Let me put a bigger number here. Let's put 25,010,000. 25,010,000. Write that on your paper. So we're going to start at the left. The first number that's not 0 is 2, and put an arrow tip. You're going to write out the number, and the arrow tip will turn into the decimal. So I'm going to have 2.501, and I'm going to stop. Then you go and you underline the numbers. The decimals right here. Underline the digits. Let me put it in a different color. Underline the digits between the arrow tip and your decimal. You would have 1, 2, 3, 4, 5, 6, 7 decimals. So I'm going to put times 10 to the 7. The 7 corresponds to these dashes. So I have 7 digits between the decimal and the arrow tip. That's the power of 10 I need to rewrite the number. Notice if my exponent's more than 1, the number's going to be bigger than 1. If my exponent's less than 1, it's going to be smaller than 1. So let's go to number 3. Notice on this one, my first number that's not a 0 is 1, and I'm going to put my arrow tip right here. So I know that my base number is going to be 1.1. Then I'm going to go back and underline between the decimal and the arrow tip. I've underlined 2 digits, didn't I? I'm going to put times 10, but it won't be a positive 2. It will be a negative 2 because this number is smaller than 1. So a negative exponent moves your decimal to the left. Positive exponent moves it to the right. Okay? So if your number's less than 1, you'll use a negative exponent. Greater than 1, use a positive exponent. Well, let's go to number 5. Notice here it's 26 9/10. Let's put our arrow tip right here. So I know that my base number is 2 69/100. And then underline the digits. I only have 1 digit underlined, and it's going to the right. It's more than 1. So I'm going to have times 10 to the 1. If I were to punch that in the calculator, it would give me this for the answer. Okay? So both of them, vice versa, it works. Okay? Let's do another real small number. Let's do 0. Write down 4 zeros. 0 decimal, 40, and then do 205. Okay? So 0.0000205. Now then, start at the left. Start at the left. The first number that's not 0 is 2. Put an arrow tip. That's going to be our base number. So 2.05. Then you go back and you underline the digits between the decimal and the arrow tip. I have 1, 2, 3, 4, 5 numbers, don't I? So I'm going to write down times 10. Since this number is smaller than 1, I'm going to have a negative exponent. So piece of cake. Piece of cake, piece of cake, piece of cake. Remember, to be in scientific notation, it has to have one number to the left of the decimal. If it doesn't, it's not written correctly. Let's go down to number 7. Okay? Number 7 is a piece of cake because anything to the 0 power is 1. So this would end up being 9 2400ths. Okay? The worksheet generator didn't generate some good problems on here, so let's add another problem. Write down 9 2400ths times 10, and let's put to the 5th power. Okay? So I have 9 2400ths times 10 to the 5th power. Since I have a positive exponent, my decimal is going to go right to make it bigger. So write down your number, 9.24, and then you're going to draw 5 dashes. 1, 2, 3, 4, 5. Every open dash will get a 0. So I'm going to add 1, 2, 3, 4 zeros. My answer would be 9240000. Put your commas. So 9,240,000. If you were to punch this in the calculator, it would give you that as the answer. Okay? That's how it works. Now then, on your calculator, so let's say you punch it in, the number's real big, and you get this, 9.3 E6. That E is the same thing as times 10. Okay? So on the calculator, when you punch in a number and it gives you an E6, that E stands for times 10. It doesn't put it in scientific notation. It uses the E for your times 10. So that's what that means. If you do it on a calculator, you get that E6. Okay? Or E12. That E is for times 10. It's putting it into scientific notation. Let's go to number 9. Okay, our decimal is right here in it. So I'm going to write down 160. Notice my exponent is negative. So I won't go to the right, I will go to the left. So 1, 2, 3, 4 dashes. Put another decimal. My 0 goes right here. So my answer would be decimal 016. And I don't have to put the other 0, do I? So that, if I punch this in the calculator, it would turn into this. Okay? That's what you would get on your screen. Let's do number 11. Write down the 2.5. And you're going to draw 3 dashes. Since the exponent's negative, we're going to go to the left. We're going to make the number smaller, right? 1, 2, 3, put a decimal. Notice we have 2 open dashes, put zeros. So I have 0 decimal 0025. Ho, 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 ho. Piece of cake. This should kind of start making sense. Notice I did the odd ones. You should be able to go back and do the even ones. Writing numbers in scientific notation isn't that hard, okay? Pretty simple stuff. You'll use this a lot in chemistry, like the weight of an atom. You'll write the weight of an atom in scientific notation. Let's go to 13. Okay, on 13 we're going to have to use our calculator, okay? So what you want to do on 13, we're multiplying here, so we're going to add the exponents, aren't we? So on your calculator, you're going to punch this times this. So let's do 1.21 times 10. Times, and then times, what are we multiplying? Times 6. Times 6, you hit enter, and I'm going to get 7.26. So I'm going to go back to here. 1.21 times 6 is 7.26, and then I'm going to put times 10, and then I'm going to do -3 plus a -1. I'm going to add my exponents up because I'm multiplying. If I were dividing, I would subtract the exponents, wouldn't I? So I'm going to get 7.26 times 10 to the -4. Now then, this is the correct answer because the decimal is in the right space. So on these problems, make sure your answer has 1 digit to the left of the decimal. If it doesn't, you got to move that decimal and change the exponent. You'll see that soon. Let's go to 15. 15, I think the decimal is going to end up being in the wrong spot. So on 15, I'm going to do the other calculator real quick because I could see both of them on here at the same time. Jiminy crickets. Oh, I turned the camera on. I don't want the camera on. Let me turn the calculator on. Calculator's right here. Okay, so I can move this around so I can do it better here. Put it over here some. Okay, so we need to do 4.2 times 3.54. 4.2 times 3.54 is 14.868. So I'm going to write down 14.868 times 10, and I'm going to do 1 plus 2 on it. Since I'm multiplying, I'm going to add my exponents. So I'm going to get 14.868 times 10 to the 3. Now that my decimal is not in the right space, is it? Okay, so this is what happens. I got to move that decimal one time to the left. If you move to the left, if you move your exponent to the left, you're going to add the number of digits, okay? If you move your exponent to the right, you're going to subtract the number of digits you move it. So I need to move my exponent one time to the right, don't I? So I'm going to do 3 plus 1 here. If I moved it 2 times, I would do 3 plus 2. So my final answer would be 1.4868 times 10 to the 4th. Notice in my final answer, there's 1 digit to the left of the decimal. If you go to the left, you add the numbers. If you go to the right, you're going to subtract the numbers, okay? So it makes sense as we go through it. Let's go to the next one. Fun, fun, fun. Yeah. So we're going to write down, we're going to do 4.9 times 8.33. Notice we are not multiplying the times 10 here, are we? We're going to get 40.817. 40.817 times 10 to the negative 2 plus 5. So this is teaching you to learn to use those exponent rules. So we're going to write down 40.817 times 10 to the 3rd power. Now that the exponent is not in the right space, is it? I got to go one spot to the left, don't I? If you go to the left, you're going to add, aren't you? So we're going to have 4.0817 times 10 to the 4. Ho, 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 ho. Fun, 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 fun. Let's continue on. Okay, this one right here is pretty simple. Remember, this is just going to turn into 1. Okay, so we're going to have 5. Let's do 5.3 times 1.8. 5.3 times 1.8. 5.3 times 1.8 equals 9.54. We don't have to move the decimal on this one, do we? And then we would do times 10, and basically 0 plus negative 4, right? 0 plus negative 4 is just going to be negative 4, isn't it? Notice the decimal is in the right spot in this one, isn't it? We don't have to move it, so we have the correct answer. So all you're doing is you're multiplying the bases and you're adding the exponent, and then if you need to move the decimal. This is teaching you what happens when you move that decimal to the exponent. Let's go to 21. On 21, we're not multiplying, we are dividing, so we won't add, we will subtract the exponents. So let's do 4 divided by 8.47. 4 divided by 8.47. 4 divided by 8.47 is 0.47, and we're going to round this to 3 digits. So just write 3 digits. Okay, so 0. Did I do that right? Yeah. Just write 3 digits. So 0 decimal 472. So 0 decimal 472. You only need 3 significant digits in most problems. You just need 3 digits, okay? Not including the 0. Now then we're going to put times 10, and then we're going to do 0 minus negative 6, aren't we? 0 minus negative 6 is a positive 6 in it. So 0.472 times 10 to the 6, and our decimal's in the wrong spot. We're not going to the left this time, we're going to the right, which means we won't add, we will subtract. So since I moved this one time to the left, I need to subtract 1. So my final answer will be 4.72 times 10 to the 5th power. If you were to do this problem, if you were to punch this problem in the calculator and this problem in the calculator, it would give you the same answer. Okay? You're just learning to move that decimal and change the exponent because you moved the decimal. Let's do 23. This is so much fun. This is a lot simpler than what you did Tuesday and Wednesday. Okay, this is kind of an easy lesson. Tomorrow, you're going to have time to work through, look over your notes, and you'll take a quiz. Okay, so pretty simple stuff. Okay, so on 23, we're going to do 5.8 5.8 divided by 40, and we get 0.0145. Notice that has 3 digits. Go to 3 digits and round off, okay? So 0.145 times 10, and we're going to do 5 minus negative 1, aren't we? We're going to do 5 minus negative 1, just go straight through, do your division rule to subtract. So that's going to, 5 minus negative 1 is 6 in it. So we're going to have 0.145 times 10 to the 6, but our decimal is in the wrong spot. It's got to move to the left 1, so we're going to subtract 1 in it. If you go to the right, you subtract. You go to the left, you add. So 1.45 times 10 to the 5th power. Ho, 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 ho. And let's go to the last one, I think. A couple of more. I'll let you do the last one on your own. Oh. Okay, so we're going to do 9 divided by 7.3. So 9 divided by 7.3. And I get 1.23, and I'm going to round that 3, so the 2 keeps it the same, right? So we're just going to write down 1.23. So if you get a big decimal, just write down 3 digits. So 1.23 times 10 to the 4 minus negative 4. So I'm doing 4 minus the negative 4. That's going to be 1.23 times 10 to the 8th power. Notice our decimal is in the right spot. This is the answer. What a blast. You can finish these up on your own. Remember, I am posting the key. I'm posting the key in the Canvas modules. If you go to the Canvas modules, don't just go to the assignment. Go to the modules, go through it. You'll see the key posted. Make sure you're looking at the key, looking at your work. Make sure you can match them up. If you need help, please message me. I will help you out. Go to the Zooms on Tuesdays and Thursdays. Hope you had a blast today. Remember, you are amazing. You were created to do wonderful things, and you are awesome.